Determine the average value of the function f of x equals sine of x between x equals 0 and x equals pi. So we know that the average value of a function over an interval a to b is given by 1 divided by b subtract a, multiplying the integral a to b of the function f of x dx. So for this question, the average value is going to equal 1 divided by, and the b take a is going to be pi subtract 0, because we're finding the average value between x is 0 and x is pi. And then we're going to multiply that by the integral evaluated between 0 and pi of the function sine of x, and we're going to integrate that with respect to x. So to evaluate that, that's going to be equal to 1 divided by pi times, and then we find the antiderivative of sine of x. And looking at your formula sheet, that gives negative cos of x. And we are going to evaluate that between 0 and pi. So that is going to equal 1 divided by pi. And then that's going to multiply everything inside this big bracket. And we're going to substitute into the antiderivative negative cos of x, the upper bound of pi. So we're going to have negative cos of pi. And then we subtract away from that the lower bound substituted in, so we're going to subtract away negative cos of 0, and yes, there are two negative signs in the middle there, which will make that positive in our next step. And now we need to remember our exact values, so cos of pi is equal to negative 1, and cos of 0 is simply 1. So this is going to equal 1 divided by pi, multiplied by, we're going to have negative 1, which becomes positive 1, and then subtract negative 1 gives plus 1, and then that is simply equal to 1 divided by pi multiplied by 2, which is simply 2 over pi. So the average value of sine of x between 0 and pi is 2 divided by pi. One way to interpret that is to consider the function f of x equals sine of x, which is sketched over here as the blue curve, and to think that the area under that curve, which would be calculated just by going from 0 to pi of sine of x dx, it has a certain area, and we average that area out over the total width of the interval that we're considering the average value for, so from 0 to pi. So it turns out that the area under that curve is actually equal to 2, and then we average it out over pi, which is something a little bit bigger than 0.5, and what we could now do is if we shared that area out into a perfect rectangle, it would have a height of exactly 2 divided by pi and a length or width of pi units going between 0 and pi. So the average value of the function is the average height of the function above the x-axis, and for this function it's 2 divided by pi, which is a little bit bigger than 0.5.